This video describes ways that a team can decide the feasibility of a project or design. You will use the systems approach to problems and include an assessment of risk, quality and safety. Here is a major engineering project in the UK. This device lifts barges from one canal to another without losing any water. As the wheel rotates, it lifts barge and water in one rotation. The full-cut wheel was a revolutionary system and an approach to a century-old problem. You will now adopt the systems approach with your thinking. Here is a system with components linked by interactions, a surrounding boundary and inputs and outputs across the boundary. Here is a systems chart for a congested freeway. This is discussed in the lecture notes. Influencing any system, including your Engineers Without Borders design and stakeholders. Include human and social considerations in your systems thinking, including those of your stakeholders. Define your system goals. For the Engineers Without Borders design, these were defined in the design brief. Ask why, what, when, where, by who, and how. Ask your team to brainstorm solutions and share them, recording possible solutions. Even offer a prize for the craziest idea. Each team member might wear one or more of these hats. For the freeway example, here is a chart of possible solutions. You might like to come back to this slide later. This chart shows that knowledge within the company is the most useful. Here are the steps in problem solving with this system, TRIZ. Net present value was introduced in the previous video on cost-benefit value, where this equation was derived. R is the discount rate, N the number of years, and this shows how present value increases, resulting from cash flows. The internal rate of return was also introduced in the cost-benefit analysis video. This is related to the discount rate, R. Here is a project. Wind farms are present in many countries, including Australia, and electricity is generated when the propellers turn. So here's the basic windmill with its measurements. Here is a table where wind farm windmills are compared for performance. A decision has to be made on the chosen model. Performance, financial and other data is collected to assist with the decision. You don't need to go into the detail of this, but it shows the range of research that has to be carried out. This is taken from the set book, and you might like to refer to that or come back to this slide. The net present value can be found in the set book. However, The internal rate of return results are on the next slide. Here are the IRR results showing that a discount rate of 11% would lead to a zero present value. These steps would assist with deciding the financial feasibility of the windmill design. This shows the many variables which make this a very complex decision. Technical feasibility. Wind farms are costly and rely on weather. However, many countries have major investments, and these are countries where the wind never rests. So location, large or small, size of towers, and so on. So here is the model once again. You will, in engineering, carry out such modelling to assist with your reports and recommendations, and that includes the Engineers Without Borders. So your models will be based on the physical laws, such as conservation of energy, mechanics, thermodynamics, and in the further years of your degree, you'll study these laws and use the computer to apply them. Now here are the calculations for the wind farm. Again, you might like to come back to this slide and just check some of the figures. You don't have to learn these formulae, but you will meet them further in your degree. Wind turbines are not as efficient as predicted, and they do have other problems. Some people have illness when they live near them. So, any results have to be verified and validated. And this may be carried out by a number of people who then compare results. So there is a hierarchy of models, balancing costs with performance and other criteria, and the ballpark is often used when making a decision. Safety is analysed and compliance with regulations has to be ensured. So whatever design is agreed, we must follow the safety guidelines. Quality assurance also is essential at every stage to ensure safety, performance and reliability. So to summarize, we've talked about the systems approach, generating alternatives, evaluating solutions, mathematical modeling, and making decisions. Thank you for listening.